Okay, here's a little bit about me. I've been a Newvalian, meaning with New Valence, since 2022. I've been building dynamic web sort of sites and servers since about 95 and network exposed APIs since 98. And like many, I failed to fix REST APIs because every time I did that, I ended up with something else. I heard about GraphQL. I can't really pinpoint it, something like 2016 or 17, and was initially terrified of its security implications because I really didn't understand what was going on. I didn't really look into what GraphQL really was, especially mutations, and then I learned more. And I'm hoping that this session will help you make your own fresh mistakes sooner than I've been able to because of all of these. So something that's helpful is to understand this session is familiarity with GraphQL, and that it is not just a stupid wrapper for other APIs, though every API is some sort of a wrapper for some other API. And it does help to understand the over and under fetching issue in not just APIs, but all over the place. The goal is to see how differences in REST and GraphQL APIs affect security in the end, either directly or indirectly, what to pay attention to, and how to make better choices perhaps for both. What I do not have as goals specifically is specific tech stacks, libraries, tools, whatever, frameworks, or their vulnerabilities, or to advertise any. So I have a question for the audience here. Who says that REST has more points of control than GraphQL? And who thinks that REST has better controls at these points than GraphQL? And who says that none of the above is true? Let's begin with the equivalent stuff. So in terms of the infrastructure, both have clients, both can have client caches, both can have the intermediary caches, like HTTP proxies, caching proxies, sometimes smarter than others. GraphQL can have its own GraphQL caches. Both of them can have security proxies, wrappers that somehow decide whether the request should pass on or not, essentially filters or gateways, and both have servers. The addressing is, in both cases, HTTP here. When we're talking about GraphQL over HTTP, there's a URL. It starts with the protocol or scheme. HTTPS has the fully qualified domain name for the host name, optional port. And then it goes, the slight differences, but still nevertheless, there's a base path for and the resource combination for the endpoint and REST APIs, and the API path and sort of the operation that's embedded inside the payload within the GraphQL APIs. But the point is that all of these concepts exist. What's important is here that we're looking at points of control. So what is a point of control for a pair of a method, HTTP method, get, post, put, delete, whatever, and a resource path is a point of control for a GraphQL operation of one of the types, such as query, mutation, or subscription. Request headers exist on both sides, and they both serve exactly the same purposes. The inputs are passed, again, generally the same way, whereas the query strings are really just normally used even in RESTful APIs for GET only, but in GraphQL, they really make only sense with the GET if you allow that. Otherwise, post bodies are for any meaningful large input. Response status, both have them. No, GraphQL is not always 200-day okay. It can have the same unauthorized or I'm busy or I failed statuses, just like a REST API can. And the response headers are again sort of the same as well between GraphQL and the REST. The response body, again, in the REST world, you're supposed to essentially communicate representational states of resources that were requested. And in GraphQL, it's the whatever the representation of the object, the part of it that you requested. So far it's one-to-one. Whatever you can do with one, you can do with the other. Maybe not in the same place, in the same way, but definitely you can. And now we're going to start with differences. So object types. The content type is really supposed to identify what kind of payload it is. That's what REST principles are at its core, the ethos and the semantic web and all that stuff. But inside, if you're, let's say, think of JSON, there are some common practices, but there's no official standard to say, oh, this part of it, this is that type. You're actually supposed to, you're advised to stay away from that. It should not be necessary. We'll see whether it is or isn't, but in terms of the in terms of that, GraphQL always exposes the type name. It's consistently available. You can actually always get it in the same standardized fashion. And what that may do, it may help some security layers, internal or external to the server, to decide what needs to be done in some cases. Then there are fine-grained errors. In the REST, you generally have just the single error. But what that means is that if you need to respond, to provide a partial response, you will need to come up with your own sort of a way to go around the REST paradigms, because you are getting around the representational states idea, which is no longer shared. So you're affecting caches, and that may require risky logic on the caching side, the cache control, and you're stepping away from the standard, which means you're inventing something. On the GraphQL side, of course, you can have errors in various different ways. Now, a lot of people start talking about REST rate limiters and comment on how they don't really necessarily work well with GraphQL. But the point is that in the RESTful world, rate limiters must account for machine gun firing due to underfetching, which is actually then amplified by sort of overfetching on the other side and then additional underfetching. So a single click in the UI or a single use case on whatever the client is may actually require a REST client to make thousands of trips. And you have to allow that for those clients to work. Whereas in the GraphQL API, the idea of a well-designed GraphQL API only will require a single trip to the server, which means that the rates are more meaningful, or your limits are more meaningful, and you can map them better. Size quotas, again, there's a frequent misconception that somehow RESTful responses are better, and that sometimes means faster or smaller or necessary, and none of that is actually true. They're usually bigger because they have overfetching and augmented by underfetching. They are not always optimized well because of how RESTful are actually implemented. They're not necessary. That's the definition of overfetching. So in GraphQL world, you have the flexibility that reminds developers to actually pay attention to this, because you can request whatever you want. And that allows you, also reminds you that you can have various forms of quotas. And again, these could be matching your real-world scenarios better. You can come up with better numbers. Which means that you can more easily recognize abnormal behavior with GraphQL than when the tools that you're using are misaligned with reality. It's hard to define limits because you have to account for both high rate to account for underfetching and high size because of overfetching in RESTful APIs, whereas in GraphQL, you can sort of understand what the clients are doing and just apply whatever quotas or whatever usage profiles you have. So who now thinks that API response caches are absolutely crucial for performance? Or headaches to keep in sync? Or security nightmares? So here's in REST API, the caches are critical for performance. That's the REST's literally only mitigation for underfetching and overfetching. There's nothing else. If you want to solve it some other way, you're no longer making a REST API, though it might seem that you are. You're not. On the GraphQL side, that's optional. I mean, you can use caches, maybe, if it really matters, but it has exact fetching and batching that will help performance anyway. So performance is not that much impacted or equally impacted with GraphQL as it is with REST. So what that means is also, because you're more dependent on caches in the RESTful APIs, you're also transmitting overfetched data. You have it littered all over the place and stored all over the place, including the client caches. And with the GraphQL, because there's no overfetching, what's not communicated simply cannot be stored. And what's not stored, what you don't have, you can't leak. So it is possible to make GraphQL safer in that sense, or they're less risky because less data is communicated in the first place. Then we enter this world of uniformity and consistency and orthogonality and how beautiful RESTful APIs are, because you can always know which operation you're going to call for, I don't know, CRUD operations like create, retrieve, update, or delete, and so on and so on, which map beautifully to HTTP methods. But here's the thing. When developers do this, they don't always know upfront which operations are needed, which ones make sense. So sometimes there's a drive to make this consistency, and they might actually expose methods that are not needed at the moment, and they might need to go into complexity, which we'll see later on, that is not needed. On GraphQL side, there's no problem with omitting something. You can always add that later. You can add whatever operations you like that make sense, and that's less of a problem, meaning you're not doing as much work that is not needed, which means you can spend time doing better work elsewhere, including security. Let's go to versions now. With multiple versions that REST API just has as the only way to manage compatibility in reality, what happens is that typically you have different bits of code still remaining to handle different versions, all of which are overfetching or sort of have some overlapped logic. You either have dedicated different bits of code for each version that have different behavior for the same thing and might leak information differently, or you have some sort of generic code that's trying to leak and re-implement past versions somehow, which again might have other risks. In either case, overfetching sort of often increases because of this, as people are trying to avoid having two versions, so they try to put stuff in thinking that overfetching is actually less of a problem, when in fact it's not, because some clients actually can be broken by seeing something that they do not expect. And this overfetching is an issue, as we noted before. This also fractures developer attention. Instead of being focused on whatever is at hand, they need to actually work on the multi-version supporting code. And on the GraphQL side, there's just no need for versioning as such, because GraphQL can expose functionality that's needed at the time that it's needed in a different way. And because there's no overfetching, there's no default fetching, there's no confusion involved in what the client actually asked for or is sending or is requiring to be sent. Let's move on to making updates. So let's consider a game of chess. I hope everybody knows enough about it. I'm not a chess player. I just know how to set up the board right and what moves are valid most of the time. And if we have a board like that and we wanted to make a player, a client of the API, be able to indicate to the API how to actually, what to do, what is the move, in GraphQL terms, we could just implement a move piece mutation, and we can pass it not only the move, let's say from E2 to E4, but also the assumed expected state of the board, so that if this is a multiplayer game, it can work out. It's relatively simple to implement. The actual server gets exactly what's needed. It can validate whether the move is in fact valid, whether the state is still as such, and actually perform that and respond to it. Now, how do you do this with the REST API? Do you send that whole new representational state like after the move? And do you know whether that's a post or a put? Are you sure about that? Maybe you just send a change, like using, for example, the HTTP patch method. And then how do you actually update caches if you use that? And then you might actually also do this, which is essentially you're creating a new action resource. You still hit the HTTP issue, and the question becomes, where did the HTTP method action consistency go? So let's take the first version, where essentially this is what the client got, and it says, I'd like the server, please make it look like this. I would like to make a checkmate with absolute domination in just one move. I'm passing the representational state how I want it to be. Of course, I mean, I don't probably need to explain this further. This is not going to fly. So there's another problem, actually. The server can't make, the reason why it's not working is because the server can't determine transitions, how we got from point A to point B, and it is the transitions that we're trying to authorize. If you don't know what transitions are, you cannot authorize. Then there's another problem. In the multiplayer chess, which is usually the kind of games that we're playing, which are not really chess, the server might have to reconcile this new update with the update with the state that's different than what the client originally had. So how does it actually decide what needs to happen here, and can it happen? So that doesn't work. Let's go to patching. Do you know how to actually patch? There's no standard for that. You would have to reinvent the wheel every time, and you have to retrain new developers. And would they actually then spend time doing that, or would they simply know how to do things and use frameworks that are helping them not have to know this, and thus spend more time, let's say, doing security better? That's custom code required. So if it's custom code, it's less tested, which means increased complexity as well, and that's additional risk. And then it's actually one patch for all the changes, and that requires GraphQL-like mutation composition, which is even more complexity in a system that doesn't actually like it, so that doesn't prefer it that way. So again, how would we do this? And this is why patching is very rarely seen. In fact, I know of it, but I've never seen it done in practice because it just fails to answer questions. So what I've seen done most of the time is that people create essentially a new move resource or action resource. At this point, the action stops being mapped to the HTTP method. There's no CRUD consistency anymore. The contextual state, remember the assumed state that I indicated on the GraphQL slide, it's gone. It doesn't have room here. If you want to have the contextual state, try to think how it would actually be even communicated, and what would that mean in terms of the exposure. Would you have to have every past state on its own be a resource so that you can post a move to it that creates yet another state? Is that it? That gets complex. And this complexity actually affects developers on both the server and the client side needlessly beyond what you would have to do, let's say in GraphQL, because you don't have these issues that way. Then you have out-of-band resource updates, which essentially means I'm creating a new resource, but that affects another beyond just a link. So it affects the new board state or creates one. And then that, of course, affects complexity. So again, we don't know how to do this relatively easily. There's another option here, which is to have every piece be its own resource, and then it works beautifully. You can just move a specific piece to whatever position you want because you're just setting that position to whatever you need. The only problem with that is to get a board state, you require like 33 trips. And you need that to either get the game state or to figure out what did the other players actually do. And then the question is, of course, how many would you would actually think of this and remember this? And how much time would they spend until they do? And how much effort would be needed to actually implement this in REST? Now you realize that this is actually sort of similar to GraphQL. You have the move, which is set to essentially be on override of a position. You would have the indication that this is a piece because it's encoded in the operation. You would have the actual move in there. We're still missing the presumed state, the board state, to make sure that the multiplayer chess or whatever still works. Otherwise, this is equivalent to GraphQL and what would be natural to GraphQL, but with in first thought in it. But it would have many links instead of actually being able to embed data within the single response. So who now has been in the situation where not all related or linked resources are visible? Let's say some documents in a folder should not be visible. So this is what I call leaky links. If you, let's say, get a folder and you want to get all the items links to items inside of it, and this could be a similar representation in there. What I typically find, not that this is correct, this is not correct even in the restful world, but it's done mostly because people think that they should only secure this. This is sort of the REST, not the approach, but the typical understanding of what they need to do. They will not go and check these links for security, for access control. They will simply enumerate them because there's the expectation that once you actually get, try to attempt to get this link, you will actually be forbidden, and that's sort of safe. The trouble is, of course, that you're leaking the fact that there is something in there that shouldn't be there. And one reason for this is, again, in RESTful APIs performance, because if you wanted to recheck security here again, it would cost additional cost on top of this underfetching that you're doing, causing additional overfetches and separate trips to get the data that you need. Let's say names of these documents. On the GraphQL side, the typical, even the simplest implementations will attempt to reuse the same fetchers very often to get things like ID and name and whatnot. And even if somebody doesn't actually implement the linkage security, what might happen is that they will fail to actually obtain the entity, which means that this will cause an exception or an error on the server and might produce a null or some other issue that the GraphQL schema will say, well, you didn't tell me that this can be null, or there were errors which would prompt the developer to actually exclude this up front. So this wouldn't appear. It would be clean most of the time. It's not about REST being better than GraphQL here. It's about the mindset the developers have and the pressures that they have when they're doing work that's different. So then, because of all this additional trips to the server, you have customers complaining about the performance. So somebody decides to add a name to it. Typical consideration here is I'm just going to add a join or whatever into the database. I'm going to get that name, and now you've got this appearing here because, well, that's all you added. You didn't actually add the security check. You just added a way to get a name. So you now leak even more. than you did before. So the truth is that because REST exposes these HATOS linking references, and because embedding other resources is considered unclean, the mindset is that, unfortunately wrong, but still there, that developers often forget to secure the links themselves and you get leakage. And this is not the case on the GraphQL side. The same or similar issue is on the search side. What if I search by that document? Similar things happen. It's almost like a search is a resource. In fact, it's not cleanly RESTful. The jury is still out whether searches can be present in REST APIs properly, or how. You could, but you have to create a search and whatnot, manage it that way. But the point is you still get those links and you can find them, whereas in GraphQL, it's really no different than the previous case. You would get nothing in there. And I can extend it further to rob you even of the wrapper idea, where that could actually check that after the fact, after it leaves the API. If you just return the count, there's no chance of anybody outside of the server knowing whether that count is accurate or not. So who now has been in the situation where the access control was down to the property type? Let's say a particular user cannot get a government ID of any person in the system. And who has gotten that even further to say, well, might be able to get for some resources or people, but not for others? Well, what do you think links are? The ones that we just discussed. They're essentially properties with property level access control. So most of you have probably been in that situation. If you have linked entities, linked resources that are access controlled, then you probably do have property level security of some kind. And maybe some of you don't have links, so you don't care. Or maybe you think that you're in the wrong meeting because you don't have access control, period. In any case, now there's a question of sort of disgraceful degradation. I'm trying to get just a name for an employee, let's say. In RESTful world, well, you're supposed to get the whole representational state, but I can't get it for some reason, perhaps because I'm not allowed to get the government ID. That's the property level security interfering. In GraphQL, well, I didn't even ask for it in this case. So it's not requested, everything's fine, I got it. GraphQL degraded nicely, REST did not. The other way that GraphQL can actually degrade, if you even ask for this information, is you can actually get errors and still get the remaining data. Or you could actually go and furthermore, sort of indicate some other way. This is unclean in either case. I'm not actually proposing this. You get a government ID of null. Here on the RESTful side, that will be a cache pollution. On the GraphQL side, I don't like it because it's not normative. You don't need caches, but it's not clean. Another way you can do is the output union pipes. In GraphQL, you can do the same thing sort of in the REST, or not REST, but in REST-ish APIs. But then again, that's a non-standard. It's no longer a representational state. It's a state for you that you cannot get something. It's an error. And it might pollute caches if you have them. And caches, again, are something that REST relies on for performance. So essentially, responsibilities are fail everything. Try to serve only what's accessible, but bring cache troubles. Don't embed ever. Always use HATOS links. But that you end up having the leaky links issue, which you must address as well, which is a complication. Or you have to actually implement something that's GraphQL-like. And on GraphQL, you saw what the possibilities are. Finally, the question is, do you think that API documentation and schema should be secret? Who says yes? Who says no? Now, do you think that documentation and schema secrecy is making it harder for your own developers to do their jobs. Who says yes and who says no? Now, for those of you hiding the schema, what will you do when your API documentation schemas leak? And they will. Will you throw the entire API out and start over? Will you hide or be elsewhere before that happens, or maybe blame others? Or will you enjoy the fame? That doesn't really apply a thing here. So how organized do you think cybercrime is? Do you think that they're just a bunch of individual losers? Or do you think that they're a well-connected, knowledgeable sharing group? And when one of them learns something, essentially they all do. They all can. It's all accessible to them. So now, after I've asked you these questions, did you actually change your mind about API docs and schema secrecy? Can you actually do anything about it if it leaks, and it will leak? And finally, I'm back to the first question. Who still thinks that REST has more points of control than GraphQL? Who thinks that REST has better controls than GraphQL? And who thinks that none of the above is true? In the end, GraphQL is not REST. Don't apply REST thinking to it. It does not work. Realize that API models do impact security, both directly and indirectly, and you have to choose well. Performance and security are at odds, almost always. Security costs some processing and you need to do it, but it's less important with GraphQL because it has more ways to offset that performance. Do not underestimate your opponents. If you code only for the weakest, it will not deter anybody else. And deterring just the weakest, or rather preparing code for the weakest, doesn't really help, because the others will still, you still have other systems in place, hopefully, to deter the others. GraphQL's flexibility better aligns with reality, which means that you can actually use that to your advantage and manage limits, quotas, actual communication between and expression between the clients and the servers. Use that to your advantage. I didn't cover tools, libraries, and frameworks. I wanted to avoid that. Both have more and less respectable versions. Do your due diligence, your own. I cannot help you. There's so many that I do not know, and I can only comment on these that I did use. And finally, nothing will protect you from yourself. You are responsible for what you make. The practices and the things that I've identified here are largely useful for both REST and GraphQL, but they should help you make better choices later on.